Hi guys, in today's video I would like to review my speech recognition AI that I've released today. It's my fifth release and it brings new features like boosted the performance of the neural network, specifically the feed-forward process, which is boosted by the factor of 5, and the back propagation process is boosted by over 9 times, and it was tested on my Intel i7, which has 6 cores and 12 logical processors, but if you have a better CPU, it's better for you. And another algorithm that I've improved is what I called adaptive learning. So when the neural network gets better, it slowly changes and lowers down the velocity and the momentum of the delta weights. So that way it is more careful when the loss gets lower and lower. So another feature that I made and is new is this what I call learning loss chart that allows you to see the training progress live. So in this training AI layout, here you can see the overall vocabulary of the neural network, but here this is how a learning or new training from scratch looks like. So there's an average loss, and the training itself, it tries to lower down the training loss of each training sample under the average value. So that's how the algorithm works. So it focuses on each training sample individually, and if it doesn't have, or if it has greater loss than the average loss, it tries to retrain it over and over again until the loss is low enough, and then it switches to another training sample. And in the process, it also adapts the training velocity and momentum of the delta weights. And this is how transfer learning looks like. In this case, it's just a continuation of the previous trained neural network, so there was no much improvement. But the average error, as you can see, it is just calculated by a low pass filter. So this is just its natural response, and the initial value of this low pass filter is 1. Because it makes sense, since I'm using this average loss as a parameter that updates the overall learning velocity and the momentum of the neurons, of the delta weights. So when the neural network starts training, when it starts to train, the initial value of this average loss is set to 1. So even the first training samples tries to go under this average loss value, and when the loss is greater than that, if the current training loss is greater than average, then it is repeated, or it can be below the average loss. But if the output neuron isn't set as the target neuron should be, if it doesn't match, it is also repeated. So the output neuron should have always the highest value according to target values. So this way, individual training samples is repeated even multiple times until it gets correct output value, or and also it has to have like the lower training current loss compared to average loss. And I've boosted the performance of this neural network by parallelizing individual neurons, each calculation of individual neurons. So these two functions, feed forward, uses parallel for each even to set input values, and also parallelizing each neuron in each layer, but individual layers are in classic serial for loop, but every neuron in individual layer runs in parallel. So this way I'm able to run it individually. So when I start this training, you will be able to see like how I'm able to use the whole CPU. So it's quite good use, like when you have the capability to use the whole CPU. Otherwise, with only the serial for loop, I would be using only one logical processor. So this helped me to boost the whole training by parallelizing all the neurons that I could have. So it still runs each layer in a serial for loop, but everything else that could have been parallelized is parallelized. So that's basically it. So here are the new screenshots that I changed. It is still just a 107 kilobyte jar file. I've also updated this README. So we have the current screenshots also of the Android application that is present since the last release. And this neural network has new screenshots, but basically they are mostly the same, but these training charts are new. And that's more or less all. So this way, as you can see, I'm able to use the whole CPU. Hopefully this recording won't be laggy because of the training, but this way the training is much better. So that's all. Thank you for watching. See you next time. Bye.